Before we begin this month's Mastertech, here's a summary of what you'll see in the tech news accompanying this program. For one thing, you'll find an article about the 1998 Mastertech Gold Tool Award. The news also contains a story about last year's Chrysler ASE Technicians of the Year. Plus, there's the monthly column listing the most recent MDS2 software updates, and another column with tech tips. So be sure to check out this month's news. Maintaining a good seal between the cylinder head and engine block has always been a critical part of engine service. With the increasing use of aluminum cylinder heads and their special sealing characteristics has come a new type of head gasket, multi-layer steel, or MLS. Welcome to this month's Mastertech. In this program, we're going to take a look at cylinder head sealing. Some of the information, such as that concerned with diagnosing a leak, applies to any cylinder head. Other information will focus on the special concerns associated with aluminum cylinder heads and multi-layer steel gaskets. In other words, the purpose of this program is to familiarize you with the practices and procedures associated with servicing aluminum cylinder heads with the new multi-layer steel gaskets. After viewing this program, you should be able to describe special sealing concerns associated with aluminum cylinder heads and multi-layer steel head gaskets, techniques you can use to check for a leak between the cylinder head and engine block, appropriate cylinder head removal and inspection procedures, cleaning methods that will not damage cylinder head surfaces, proper gasket and fastener installation procedures, and proper follow-up to ensure a good repair. In this segment, we're going to look at some of the characteristics of aluminum cylinder heads and multi-layer steel gaskets that affect sealing. Let's start with the cylinder heads. First of all, cylinder heads that are made of aluminum have roughly twice the expansion rate of cast iron cylinder heads. The result is greater expansion and contraction as the engine heats and cools, and a corresponding need to maintain a good seal with fasteners that have been tightened in the proper sequence to the correct torque. Also, aluminum's expansion rate combined with its flexibility means that overheating is more likely to result in warpage and a seal leak than with cast iron cylinder heads. As a result, it's particularly important to follow the recommended procedures when servicing the cooling system, to track down and correct the causes of engine overheating, and to carefully examine the cylinder head on an engine that has overheated. The fact that aluminum is softer and more flexible than cast iron also means that incorrect removal, cleaning, and installation procedures can damage it, and that you'll need to examine it closely for cracks and corrosion. Of course, on the plus side, aluminum cylinder heads are much lighter than those made of cast iron, resulting in significant weight savings. In the past, composite and graphite head gaskets have provided effective sealing for aluminum cylinder heads. Composite gaskets use a fiber facing on a steel core. Graphite gaskets also use a steel core, only with a graphite facing. Changes in gasket technology have led to the increasing use of multi-layer steel gaskets for a superior seal. As its name implies, the multi-layer steel gasket uses several layers of stainless steel. A thin rubber coating between the layers provides sealing. Currently, multi-layer steel gaskets are used in all 2-liter and 2.4-liter four-cylinder engines with rear exhaust, and they replace the composite gaskets used for servicing these engines in previous model year vehicles. You'll also find these gaskets in 2.7-liter, 3.2-liter, and 3.5-liter aluminum block V6 engines, and in the 4.7-liter V8 engine used in Grand Cherokee. The Viper V10 engine also uses this gasket design. The multi-layer design has a number of advantages. For one thing, because of its uniform thickness, the MLS gasket is less likely to cause bore distortion after the cylinder head is installed. The multi-layer steel gasket is also more resilient than other gaskets. So, after being compressed, it bounces back to form a good seal. Because it provides an almost seamless transition from a cylinder head to block, a multi-layer steel gasket also contributes to lower emissions. While the multi-layer steel gasket is designed to provide a superior seal, it is not a cure-all for cylinder head or block imperfections. And, as we'll see later, you still have to inspect these components thoroughly to ensure that they can provide a good surface for the MLS gasket to seal against. Now, try this review question to check what you've learned so far. You may want to pause the tape to discuss the question as well as the material in this segment before answering. Which of the following describes the properties of aluminum versus cast iron cylinder heads? A, aluminum is softer. B, cast iron expands at twice the rate. C, aluminum is more rigid. D, cast iron is lighter. The answer is A, aluminum is softer. For that reason, you'll have to be particularly careful when servicing aluminum cylinder heads. When diagnosing symptoms that could be caused by a cylinder head seal leak, it's important to make sure that the cylinder head seal is in fact the cause of the symptom. Both oil and coolant can travel from external leaks in other locations to the cylinder head seal area. So it's critical to check all potential leak sources. In the case of oil leaks, that means such items as the cam sensor seal, the cylinder head cover gasket, and the PCV connections. In cases that are difficult to diagnose, you may need to use dye that is sensitive to ultraviolet light to pinpoint the source of the leak. Instructions for conducting this and the air leak detection test are located in Group 9 of the service manuals. They will also be covered in an upcoming Mastertech, so be sure to watch for it. In some cases, such as when a warm engine emits large amounts of steam from the exhaust, it's pretty obvious there is an internal coolant leak, possibly from the cylinder head seal into one or more cylinders. Another obvious sign of an internal leak is spark plugs that are fouled with coolant. When the leak is not quite so obvious, you may need to pressurize the cooling system to check its integrity. You may also need to check the coolant for oil, or you may need to use a chemical test to check for exhaust gases in the coolant. The point is to determine, based on the symptoms and the tests, exactly what, if anything, is leaking and where it is leaking to. Once you've established the approximate location of an internal leak, you still need to disassemble engine components and visually inspect the area to confirm the cause. Remember, a leak between coolant and oil passages, or between these and the combustion chamber, is not necessarily proof that the cylinder head seal is at fault. In addition to the cylinder head seal, a crack in the cylinder head